Hi, in this video, I want to talk about causal analysis using R and how to do the G estimation by using the R package called Causal Models. Okay. So first, make sure the package Causal Models is installed, and then you can load in causal models, and also we can load in the data set called causal data, and we use the data set called NHEFs. Okay. And first, let's remove all the missing data using NA. We're just using this command. Anywhere there's missing data on the weight 82, then we remove it. Okay. And then we hold the quit smoking as a factor. So this will be our exposure variable. Okay. And the confounders are a list of variables including sex, race, age, education, smoking intensity, smoking years, exercise, active, and WT71. Okay, to use the package causal models, first we need to initialize the parameters. So here we can say init underscore params outcome equal to WT82 and 71. I think that the weight change from 71 to 82. Treatment is quit smoking. Covariates are the confounders we just defined. The data equal to an HEFS dot no missing values. Simple equal to false. So after we have done this, we set up the G estimation model. Okay. So first we can use the G estimation, which fits structural nested mean model, SNMM. No, SNMM for estimating causal effect of quit smoking on weight, after adjusting for the confounders. Okay. So the G estimation fits a structural nested mean model by solving special estimating equations that explicitly model treatment effects conditionally on covariate and treatment history. So it's a direct estimate of the causal effect, and it's marginal because it's population average. It's a marginal causal effect. Okay. So the syntax is pretty simple. Just use the G estimation, the data set, and type equal to 1.linear, n dot boot equal to 150. So type equal to 1.linear is we're using a one parameter linear model, and this is suitable for continuous dependent variable. Here is the weight change. Okay. And we do need the bootstrap, and we specify number of bootstrap sample is 150. So we can run the model. It's very easy to estimate. So now here you can see the output is average treatment effect of quit smoking. The beta 3.467, that is the average treatment effect. Okay, that's the marginal treatment effect. Okay, after controlling for confounders. And also it gave us a 95% confidence interval, which is 2.356 to 4.578. So 0 is outside this interval, so they indicate a significant direct causal effect. Also, since we have a package, we can easily do several other type of causal estimates. For example, we can do standardization estimation. And standardization involves fitting an outcome regression model conditional for each treatment level. It is the population average, or we call marginal causal effect. Okay? And it's suitable for fixed covariates. Okay? So here, the implementation is very simple. It's a standardization on that data set. And you can see the outcome here. It is pretty easy. We can look at the average treatment effect, and this is the marginal effect, and also the 95% confidence interval, is also does not contain 0. Okay, and if you pay attention, it also gives us an AIC value. So meaning this model estimation is done by maximum likelihood, and with AIC we can do model selection, variable selection pretty easily. Okay, and the next one is the inverse probability weighting estimation, and this is use a weighting mechanism by weighting each subject by the propensity score. Okay, the inverse probability of receiving the treatment they actually received. And it is also estimating marginal causal effect, and it's suitable for time varying covariates and confounders. So it is good for handling time varying covariates because you can calculate propensity score also for each different time point. Okay. So the implementation is fairly straightforward, just using IP weighting, and then you can see the average treatment effect. So just keep in mind this causal estimate is after controlling for the confounders. Okay, and this one gives us a similar results. You know, it's the 95% confidence interval is outside the 95% confidence interval. 0 is outside that confidence interval. And the next one is called the Doubly Robust Estimation, combining standardization and IPW. It has two models. One model for the outcome of given treatment and the covariates is called the outcome regression. The second model is for treatment assignment. This is for propensity score model. Okay, so this one is very sophisticated and it has good properties. The estimates are unbiased and consistent, even if there's only one model correctly specified. Okay, so this is why it's called robust. So you have two models you can specify. You just need to get one of them right, and you get a good estimate. Okay, and this also estimates marginal causal effect in the presence of time varying covariates and confounders. And also the function is doubly underscore robust. So we can run it very quickly and we can summarize it. And since this has two models, so the output is longer. The first one is the outcome model. You can see this is the weight change to regress down the exposure plus all the other covariates. And the second model is the propensity score model. So this is the quit smoking and regress on other covariates. So for estimating the propensity score. Okay. So here, let's see. In the first model, it also outputs the average treatment effect, but unfortunately, it doesn't have the standard error. So if you want standard error, you have to do something extra. Okay. All right. So if you want to do a little bit comparison, so here we can calculate the 95% confidence intervals for different methods, except the except the doubly robust method. Okay, so here we can create a data frame and put the lower limit and the upper limit, and then we can plot them out and look like that. Okay. And also we can do some sensitivity analysis or subgroup analysis by age. So here I'm just demonstrating subgroup analysis. So if you want to divide, you want to cut the age by 18, 40, 60, and 80 and into subgroups, then you can just do this initialization and do G estimation for each subgroup. And then it will give you the estimate on these different subgroups. Okay, so this is a demonstration for you how to do subgroup analysis. Okay, all right, so we are happy that we have actually a package for implementing G estimation. Okay, and thanks for watching, and please like our video, click on the notification, and also subscribe to our learning channel. And you're welcome to ask questions or make suggestions in the comments area. Thank you so much.